This video will describe another example of using the inventory model to calculate inventory strategies for the order quantity and reorder point under several different sets of assumptions about service level, fill rate, and expected shortage cost. So we want to go end to end here and look at all the different inputs. So there's some assumptions here on the Inventory2 file that we'll use. But what we're assuming here is we want to use a 3-period weighted moving average forecast. So this is for product L in the product sales data set. So on this tab product L, we have this forecast, and our assumption is that we want to select the weights to minimize the mean squared error. Now, those weights are in here right now, but just to see how we got those weights, as an example, we could start with equal weights. The mean squared error is 94,739, and notice we left out the first 3 weights because this is a 3-period weighted moving average. And if we go to Solver, it's set up to minimize mean squared error by changing these weights. Okay, so we get the weights and we get the forecast. Now, if we go to the bottom of the forecast, what we're really wanting, we can see out here the forecast goes out 12 months for this product. And so notice the year here is 2022. So this is the 2022 forecast, the last 12 months. 42,673. That'll be our mean annual demand. So we used that forecast. We selected the weights to minimize MSE. One of the other assumptions is there are 300 working days per year. And so on average per day, the mean daily demand is 42,673 divided by 300. Now, one way we can use the forecast to estimate the standard deviation of daily demand is to use the mean squared error. So we notice the mean squared error is 79,389. Right here, if we take the square root of that, we would call that the root mean squared error, RMSE, and that's a monthly number. Now, if we're assuming 300 working days per year, that would be 25 working days per month, because 300 divided by 12 is 25. So we could go ahead and calculate. We use that as an estimate of the standard deviation of daily demand. That is the root mean squared error divided by 25. So that's 11.27. Now, these tabs here, the lead time tab, the sales tab, and the products tab, are just repeated from the product sales data file. But they have over here on the products tab, we're dealing with the wholesaler. They have the different costs for the wholesaler. So the fixed ordering cost for product L is 200. The holding cost percentage is 1.75, which is actually 175%. So this is a highly probably perishable type of a product. And actually this product L was really meant to mirror a lot of the data and assumptions from the beer game. So we'll put in here 1.75, and the annual storage cost was 5. Now, what we need is the average purchase price. There's an assumption over here we'll use is that the average sales price is 10% higher than 2021 here in this new year 2022, and that the average purchase price is 70% of the average sales price. So what we can do, we have all the sales on this tab here called Sales. So we can create a pivot table. So we'll insert a pivot table. And we can do it on a new worksheet or existing. We'll just keep the new. All right, so let's have a filter on product and a filter on year because we want to examine 2021. And then what we want for the values is let's do revenue and let's do sales. And so what we can do here is filter on product L and filter on 2021. So here's the sum of revenue for 2021, the sum of sales. So the 2021 average sales price would be the revenue for that product in that year divided by the sales, right at $16. Now, we've said that we want, we expect the average sales price was going to increase by 10% in 2022. So in other words, we expect that 2022 average sales price will be the 2021 price times 1.1, an increase of 10%. So then what does that make the average purchase price? Well, our purchase price as a percentage of sales price is an assumption that's given to us. It's over here. It's 70% of the average sales price. It's also in this products tab, 0.7. So that's 0.7. And so the 2022 average purchase price, which we're using P, is about 12.33. Now, once we do that, we can calculate the holding cost per unit per year. And so that would be the storage cost plus the purchase price times the holding cost percentage, which is very high for this product, 26.58. All right, now if we look at our summary, the first thing we're going to do is just look at the EOQ model. For the EOQ model, the only cost we consider are the annual ordering cost and the holding cost, and we're leaving out safety stock for right now. So if we take our expected annual demand divided by our order quantity, we'll get the expected orders per year, and it would probably be best just to put in a starting value for order quantity, say 1,000, so that we can see this number calculate. And then that would give us our annual ordering cost. If we multiply it times the fixed cost per order, which is 200. Now, our holding cost, our average inventory is 0.5 times Q. And for right now, since we're just calculating the EOQ, we're going to ignore the safety stock. And our holding cost will be 0.5 times Q times our holding cost per unit per year. And so our annual inventory cost are annual ordering cost plus annual holding cost. Okay, so now we can set up Solver to find our economic order quantity. So we would want to have as the objective our total cost, our changing cell will be just order quantity, and then the only constraint we'd have to have right now is just that our order quantity is greater than or equal to 1, and that'll just keep us from having errors in our spreadsheet. So that should give us our economic order quantity, and it's 801. Not surprisingly, its economic order quantity is where the annual ordering cost is exactly equal to the annual holding cost. So we'll record this over on the summary. So it's 801 for the EOQ. The EOQ, we're not considering the uncertainty yet, so these values would all just not be applicable. Our annual ordering cost is 10,649.61. Our holding cost is the same thing. We're not considering shortages yet, so our total inventory cost would just be the fixed ordering cost plus the holding cost. And again, we're not considering uncertainty yet with just the EOQ, so we don't have a service level or fill rate yet. So that would be how we would get the economic order quantity and all of the inputs for this product L inventory problem.